y parameters. The same as earlier analysis. Here, this is my network, port 1, and this is the port 2. Now, this is my V1 and this current is I1, and this is my V2 and this current is I2. This is I1 and this is I2, isn't it? Right. Now here what we do is, previously what we did it is, and we have selected, what we selected, V1 V2 as a dependent. Now we'll take the V1 V2 as a independent, I1 I2 as a dependent. Simply reverse, nothing else. Here we are taking this thing as a V1 V2, we are calling them as a independent here in this case. Independent variables. I1 I2 we are taking as a dependent variables. I1 I2 we have taken as a dependent variables. Then we will develop these equations now here. These equations are, what we can say here is as I1 is equal to y11 v1 plus y12 v2. Next, I2 is equal to y21 v1 plus y22 v2. Right, and I can express this is the matrix form, I matrix, which I can call it as what now here, Y matrix into V matrix, I can say Y matrix into V matrix, I can say. Yes, this is I matrix, Y matrix, V matrix, we should write. Now we'll see these parameters now, one by one parameters. How to find these parameters now? First one, y11. Tell me this y11, which is given as what? I1 by v1 when v2 equal to 0, and you can see what the units are mho. So what I can call this is a, so same port means we used to call them as what? Driving point. And generally we used to call port 1 we are calling as input, and second port we are calling as output. So driving point. So this is what now? Current by voltage. So this is what? Admittance. This is the driving point, input, admittance. Next, y21. Tell me y21 is a I2 by v1 when v2 equal to 0. And what are the units are here? Ohms only. y21. This is the y21 now, I2 by v1. So what I should call this as a transfer. One port to other port transfer, forward transfer, reverse transfer, forward transfer. So I can call this as what now? Forward transfer. Forward transfer what? Admittance. Forward transfer admittance. Next, tell me y12 is what? I1 by v2 when v1 equal to 0. And what the units are? Mho. Now tell me what I should call them as a forward or reverse? Reverse reverse transfer admittance next, or the next one is a y22, which is given as I2 by V2 when V1 equal to 0. Tell me what it is a mo. What I should call this as a same port means a driving point. Driving point output admittance. Driving point output admittance, isn't it? Now you can see here, so to get these parameters, what we should do, v2 0, v2 0, v1 0, v1 0 means what now here? v1 0 means port 1 must be shorted, voltage 0 is shorted, and second port must be shorted or not. So that's why, and this y parameters we can also call them as a y parameters is also called as a short circuit parameters. Y parameters is also called as a short circuit parameters, and these are also called as, here see the units are mhos, so that's why these are also called as a admittance parameters. Admittance parameters. Now we'll develop the network for these equations. Here it is overlap. We'll develop the network for this equation. This is I1 now. So what I should call, this is the KCL equation. This also KCL equation only now. Can I develop the network for this thing here? Tell me what we can say here. The network. So since KCL equation we can call it as a Norton equivalent, we can develop it. Now here this is the port 1, this is V1, this current is I1, and here this is port 2 V2, and I can say this current is I2, I can say, and this, what I can say, this is now Y11. Yes, I1 is equal to Y11 ohms, no, mhos, sorry, admittance mhos, and then this current I can say this as Y12 into V2. Next, this is Y22 mhos, and this current is what? Y21 into V1. Check it now. If I apply KCL at this node now, KCL at this node, tell me now here, I1 is equal to this current plus this current. Yes, and at KCL at this node, this current I2 is equal to this current plus this current. We'll get like this. right? Now you can see the condition was symmetrical and reciprocal. Yes, if y11 if it is equal to y22, then the network is said to be symmetrical. The network is symmetrical. Next, if y12 equal to y21, then the network is said to be reciprocal. Reciprocal. Same as like earlier Z parameters. And previously we have seen what we have seen, it is a the Z parameters. This is a relation of V matrix equal to Z matrix into I matrix. Right. Now here this is from Z parameters V matrix, which is equal to what? Z matrix into what I can say, I matrix. This is this thing here. So what I am doing is I am multiplying both sides with a Z inverse. Multiplying both sides with Z inverse. Then what happens now here? The Z inverse into V matrix, yes, which will be what now here? Z inverse into Z will be I matrix now, unity matrix, identity matrix. So this, if you multiply, you will get this thing as a I. So from this, what I can say now here, this I matrix, which I can write it as what? Z inverse matrix. Hope you all of you know this thing in your matrix analysis. I matrix Z inverse into V now. So this thing. Now just now we have seen now this matrix. Look at now this matrix now here. Y parameter matrix is what? I matrix, which is equal to what? Y matrix into V matrix, isn't it? How can I compare these two equations now? Can I compare these two equations? From this, what I can say here? From this, what I can say here? So these two must be same. So from this Y matrix, which is equal to what I can say here? Z inverse. Now if I take inverse on both sides, then what happens now again? So this is Y inverse. The inverse of inverse will give the same matrix now. So this I can say it is a Z only. So from this, what we can say here? Y matrix is equal to Z inverse and Z inverse equal to Y matrix, vice versa. Y inverse equal to Z matrix only now. Right. This is the condition. This is the relationship between the